Hi everyone, so this video will go over inverse ratios or identities. I'll call them ratios for now. I'll remind you of the right angled trigonometry that you are already familiar with, opposite, adjacent. So the three first ratios that you learned with respect to the sides in the right triangle are sine, which we know as opposite over hypotenuse, cosine, adjacent over hypotenuse, and tan, which is opposite over adjacent. Now, the inverse ratios are basically looking at the inverse here. So what if you wanted to study, or if you wanted to look at the relationship between the hypotenuse first and then the opposite? So the three inverse ratios are called secant, cosecant, and cotangent. So these are, I just wanted to show you how they're pronounced. The abbreviations are SEC, the secant of an angle. And the secant of an angle is just looking at the relationship between the hypotenuse and the adjacent side. Okay, so look at the top, see which one is the inverse of. Cosecant is looking at the relationship between the hypotenuse and the opposite. And cotan, this is the easy one, cotan is looking at the relationship between the adjacent and the opposite. So I didn't do them in order, but I hope you can see that secant is just the inverse of, so unfortunately the letters don't correspond, of cosine. Okay, so you see how there's an S here? It doesn't correspond. So it's inverse. So secant, what is the secant of the angle? It's just the inverse of the cosine. Or in terms of the ratio, it's the hypotenuse over the adjacent. The cosecant is the inverse of sine. And the cotan is the inverse of tan. Now, cotan is the only one that sort of gives it away. Oh, I'm running out of, I see that I'm not on my screen here. Okay, so let me just make sure. So cotan is adjacent over opposite, and cotan as an inverse is 1 over tan. So as I was saying, cotan has the only one that has the word tan in it. So it's the opposite. Cosecant is sine, and secant is cosine. Now, by the end of this video, I want you to know how to find the exact values of the inverse ratios from the unit circle. So this is the relationships, these are the three ratios that we will use. I'm just going to rewrite them in red. We are going to use the fact that, no, you can't see that there. I'll do it here. That secant is the inverse of cosine, which means if you have the cosine of an angle, you invert it, you should have the secant. Cosecant, opposite, right? Not CS, is the inverse of sine. And for tan, sorry, no, not tan, cotan, we are going to use another inverse. So here, let me see if I can remind you. Tan, if you saw the other video, is sine over cosine. So an easier way to do cotan from the unit circle is cosine over sine. Okay, so these are the three inverse ratios. So now I'll just do a few examples of how we find the exact values from the unit circle. So let's look at example number 1. What is the exact value of the cosecant of pi over 6? Well, I don't have cosecant in my unit circle, but I do have, so cosecant, not cs, I do have sine. So this is like saying, what is, sorry, that's not what I wanted to say. I wanted to say, if you can find the sine of pi over 6, you can invert it to find the cosecant. So see what I'm doing there? I'm replacing the ratio by its inverse. So from the unit circle, right? Hopefully you've memorized it by now. If not, you would have it on page 94, I think, of the workbook. So let's say I had my unit circle right in front of me. Pi over 6 is there. Pi over 6, okay, you can't see that on your circle, on your image, sorry. Pi over 6 is root 3 over 2 and 1/2. Okay, what happened here? So that's the cosine and the sine. I need sine, so that's 1/2. So the cosecant, I've replaced now sine of pi over 6 with 1/2. Dividing by a fraction is multiplying by the reciprocal. The cosecant of pi over 6 is 2. Okay, I'll do another one right here. What is the secant? Let's do secant. I guess we can do the same angle since I have it right in front of me there. The secant of pi over 6. Same idea. I don't have secant on my unit circle. Let me rewrite it as the inverse. The inverse. I would go to my unit circle. I would look for the cosine of pi over 6, which is right over there. Cosine of pi over 6. Now, this is a messy value. Multiply by the reciprocal, which eliminates this. We have 2 over the square root of 3. Irrational. Okay, I went over rationalizing a little bit in one of the videos. I hope you can see that on your screen. Pi over 3, not pi over 3, root 3, root 3. I'll do it down here. 2 times root 3 is still square root of 3. Radical times itself is just itself. Okay, and then I'll do one more. I'll do cotan. So the cotan of 5 pi over 3. So remember, it's the tan of 5 pi over 3, but that's not in my unit circle. So I will use the fact that it's also cosine over sine. Okay, remember you can ask me questions at any time. So now let's see on my unit circle. I don't have my unit circle completely drawn. Can I go back to it? Yes, so this would be pi over 3, 2 pi over 3, 3, 4, 5. So I just wanted to see the quadrant. So that's, let me put that in blue here. The trigonometric point of 5 pi over 3 is 1/2 negative square root of 3 over 2. Okay, so I know you can't see that. So let me I'm a little bit limited with my screen. Let me do that here. So 5 pi over 3 on the unit circle, which you have in front of you somewhere, hopefully, is negative 1/2 negative root 3 over 2. So this one here, we just have to replace the values. So cosine is 1/2. Cosine is 1/2. Sine is negative square root of 3 over 2. Remember, dividing by a fraction is multiplying by the reciprocal. Okay, so I can see that I've already run out of room on my screen. So just bear with me a second. I'll try to squeeze that in a little bit better. We're almost done. Okay, so multiplying. Here, we're back here. I have this fraction. I'm going to multiply by the reciprocal. Okay, see what I did there? I flipped and I rewrote. This is my multiplication dot. Hopefully you can see that. Now, with the 2's here, I can just cancel them since they would cancel out. And I'll write it here. We would have 1 over this radical here, root 3, irrational. Okay, so I won't explain this at every step. And my answer, I'll work on this side. 1 times the square root of 3 is the square root of 3. And a radical times itself is just the radicand. Okay, so I hope this helps. And you'll have some examples in your assignment soon.